You know the feeling, right? Anyone who's ever written code does. You run your script, you're hoping for the best, and then crash. It's just a universal moment of frustration. But what if you could turn that chaos into something elegant, something resilient? Well, let's dive in and see how.
Yep, that sudden stop, that wall of red text just staring back at you from the terminal, it feels like you failed, but really, it's not a failure at all. It's feedback. And learning to read that feedback is the first big step from just, writing code to actually building professional, rock-solid applications.
And this gets to a really fundamental truth, something Python's creator, Guido van Rossum, pointed out. Your code isn't just for the computer. It's for people. It's for your future self. It's for your teammates. And this whole journey, from figuring out errors to writing clean code, it's really all about one thing: communication.
Okay, so let's start with that feedback. The Python documentation breaks it down for us, saying there are basically two main kinds of errors we're going to run into, and knowing the difference between them is absolutely crucial. So on one hand, we've got syntax errors. Think of these like bad grammar. You've missed a colon or a bracket, and Python literally can't even understand what you're trying to say. The program won't even start. Then, on the other hand, you have exceptions. Now with these, your grammar is perfect, the code makes sense, but something unexpected happens while it's running, like say trying to divide a number by 0. The program starts, but then, bam, it hits a wall and crashes. So if these exceptions are going to pop up while our program is live, how do we stop them from blowing the whole thing up? Well, we build a safety net. And in Python, that safety net is called the try and except block. And honestly, it's super straightforward. You're basically telling Python, hey, listen, try to run this bit of code for me. I think it'll work, but I'm not 100% sure. If something does go wrong, instead of everything crashing, Python just calmly jumps over to your except block and runs that code instead. It's your plan B. But we can actually get even more specific with our plan. It's like a full 4-step process. First, you try the risky code. If that fails, Python jumps to step 2, the except block, to handle the problem. But what if it works? Well, that's what step 3, the else block, is for. It only runs on a success. And then there's step 4, finally. This is the part that is guaranteed to run no matter what, success or failure. It's perfect for things you absolutely have to do, like cleaning up resources.
And here's where you see the real power of this. Look at the before example. If you ask for a number and the user types hello, your program just dies. End of story. But in the after example, we've wrapped that same code in a try except block. Now we catch that specific value error, we give the user a nice, friendly message, and the program just keeps on chugging. You see? This is the difference between a brittle script and a genuinely user-friendly application.
Okay, so catching errors is great, but what if I told you that sometimes the professional thing to do is to create errors? On purpose? It sounds weird, but it's all about taking proactive control, and Python gives us the tools to do just that.
Using the raise keyword, you can intentionally trigger an exception. Now, why would you do that? Well, it allows you to create your own custom exceptions. So instead of some generic error, you could raise something super specific, like a password too short error. See how much clearer that is? And beyond that, Python gives us elegant tools like the with statement, which automatically handles cleanup for you, like making sure a file gets closed. It just makes your code safer and cleaner.
And all this talk about being proactive and clear, it leads us to the ultimate form of control. Writing code that's so clean, it actually helps prevent errors from ever happening. And for that, the Python community has a shared blueprint, PEP 8.
So what is this PEP 8? Well, PEP stands for Python Enhancement Proposal, and number 8 is all about style. It's got nothing to do with making your code work. It's all about making your code clean, consistent, and easy for any other Python developer on the planet to pick up and understand.
And this isn't just some random suggestion. It's a core piece of the language's philosophy. I mean, think about it. If your code is hard to read, it's going to be hard to debug, hard to maintain, and a nightmare to collaborate on. In Python, readability isn't just a nice-to-have, it's a feature.
The real power of PEP 8 is in its consistency. It gives us these simple, really memorable rules. For functions and variables, we use snake case. For classes, it's camel case. And for constants, we use all caps. So when you see Python class in somebody's code, you don't even have to think. You instantly know it's a class. It's like a shared visual language, and it's incredibly powerful.
79.
Okay, this number might look totally random, but it's actually one of the most famous rules in PEP 8. It's the maximum number of characters you should have in a single line of code. It's designed to stop you from having to scroll sideways and forces you to break down complex thoughts into smaller, more readable chunks.
And that line limit is just one part of a bigger set of layout rules. Things like use 4 spaces for every indent. And please, use spaces, not tabs. Use blank lines to separate big chunks of your code. It's not just about making it look pretty. These rules structure your code visually, guiding the reader's eye and making the logic way easier to follow.
So when you put all of this together, the error handling, the style guide, you start to see this shift in perspective. You move from just being a coder trying to make something work to being a craftsman who's building something well. You're creating code that isn't just functional, but also resilient, readable, and easy to maintain.
So, what's the big takeaway here? Well, first, errors are just feedback, not failure. Remember the difference between a syntax error and an exception. Second, use try/except to build programs that don't just fall over at the first sign of trouble. And finally, follow PEP 8. Not because someone is forcing you to, but because readable code is just plain better code. It's an investment that pays off every single time you or anyone else comes back to it.
And this really is the beauty of Python. Both the exception handling we talked about and the PEP 8 style guide, they both push us toward this ideal. They give us a clear, obvious path to build software that is both strong and understandable. It's about getting rid of the chaos and choosing to code with clarity and purpose.
So I'll just leave you with this question. The next time you sit down to write some code, think about the next person who's going to read it. Even if that person is you 6 months from now. Are you just writing a list of instructions, or are you telling a clear story that's actually built to last?